Okay, in this video, we're going to remind you how to solve systems, linear and quadratic systems with substitution elimination. We're going to start out with a linear system here, and we're going to show you both methods with it. So first off, substitution. Substitution, we get either in one of our equations, either x or y by itself. We've already got y by itself in the first equation. And we make a substitution into the other equation. So we're going to rewrite 2x plus 3y equals 7. Taking out the y and plugging in from the first equation what it's equal to. Solve it like normal, and I think this problem's a little bit ugly. Let's use distributive property. That's going to be plus 9x minus 12. Combine all your like terms. This right here is a total of 11x. In order to move minus 12 over here with a 7, we're going to add, and we get a value of x equals to 19/11. Like I said, a little bit ugly. In order to find the y value, we then go back to the either equation, doesn't matter, and our y value is going to equal 3 times, we're making another substitution, 3 times 19/11 minus 4, which will be 57/11 minus 4, which is going to equal common denominator. That's going to be 57 over 11 minus 44 over 11, which gives me a y value of 13/11. So our answer there is going to be 19/11 for my x and 13/11 for my y. Now we can also solve this with elimination. Now with elimination, we have to get everything lined up. So in my first equation, I'm going to take this 3x and put it on the other side and write it as negative 3x. Leave my y where it's at, and it's going to equal negative 4. The second equation is already lined up like I want it. 2x plus 3y equals 7. We're going to multiply anything you want to one equation, both equations, either equations. It doesn't matter. But what we want to do is we want to be able to add these two equations together to get something to cancel. Just to show you that you can do it to both equations, I'm going to do this. I'm going to take my whole first equation, multiply it by 2, and you'll see why in just a second. Negative 6x plus 2y equals negative 8. Notice how I multiply all three terms. In order to get my x's to cancel, I'm going to take my second equation, multiply everything by 3. Turns this into a positive 6x plus 9y equals 21. And again, now we're going to add the equations together. A negative and a positive of itself is going to cancel. It gives me 11y equals 13. Next step, divide by the 11, and you get y equals 13/11. And I'm not going to go back and plug in, but that's what you do next, and you would get this exact same answer. Okay, the next one, we have a quadratic system. Got a quadratic and a linear. So pretty much what you've got is that going on. So there's a good possibility you're going to have two answers on this. Now, on most of these, it's going to be simpler most of the time to use substitution. So what I'm going to do in my second equation, I'm going to get y by itself. And the way I'm going to do it, I'm moving y to this side since it's a minus y, and I'm moving 8 back over here. And that gives me 7x, stays put, 8 turns into negative 8, and what I want, negative y, turns into positive y. And notice now you've got y by itself, and you've got y equals something. So you're going to make a substitution into the other equation. You're going to take out the y and put in 7x minus 8. Equals x squared plus 3x minus 5. Then you have a simple quadratic equation. To solve a quadratic equation, we're moving everything to the same side. 7x becomes minus 7x, and I'm subtracting it from this. A minus 8 becomes a plus 8, and we're going to add it to this. We can solve this, I believe, by factoring x and x. What adds to give you negative 4 multiplies to give you a positive 3, will be a negative 3 and a negative 1. Set each of those equal to 0, and you're going to get two x values of 1 and another x value of 3. Now, again, what you're seeing here is more than likely this has two solutions. In order to find the y values, you simply take those x values one at a time and plug it back in. You can plug it into either equation, but I think this is going to be the easiest place to plug it in. So when x is 1, you have 7 times 1 minus 8, which is negative 1. When x is 3, you got 21 minus 8, which is 13. There's your two solutions. Okay, let's solve one more of those. Now, this one's going to actually end up a little bit easier than what we thought it was going to. Now, you can, let me show you this. You can use elimination on these. So notice how everything's kind of lined up. I'm going to make it line up even better y equals x squared, and I'm going to skip a little space and put minus 5, and then you've got y equals x squared plus 2x plus 3. So to get things to eliminate, and we've got to get either all of our x's or all of our y's to eliminate, and it's going to be very easy to get my y's to eliminate by multiplying the first equation by -1, and this happens. Now, again, substitution would have probably been easier. I'm just showing you that you can do it both ways. Negative y and positive y cancel each other out, but we do need to put a 0 there so that we have something to the left. And actually, x squared and negative x squared also cancel out. When we add the rest of these together, I get 2x, and I get plus 8. Solve what you have left. 8 moves to the other side and becomes -8. 2 we're going to divide by, and it becomes x is -4. So this thing is only going to cross at one point somehow. So, and again, what you've got is two parabolas here crossing at a single point, and that point's going to be -4, comma. Again, x is -4. To find the y value, we're simply plugging that in. When you plug in -4, and this is probably the easiest one, my x value is -4. That's going to give me 16 minus 5, which is 11. So my single intersection point is going to be -4, comma of 11.